Hi there. So here we are again with a new kind of setup. You can see it over here. This time it is a setup that I usually call divide and multiply setup. You can probably read it already over here. And as we ended the previous setup over here, this would be the additive or the combined additive and subtractive setup. We ended it by saying that there is a setup that can fix or deal with this potential issue of getting negative pixel values when you grade down across multiple sets, AOV sets. And this over here is that setup. And I'm not going to lie, the setup has been a favorite for me for the last couple of years. I use it whenever I can. And as I already said, I used variants previously. I used variants of this kind of setup we had going over here. So maybe not always looking the same, but using the same principles. And I used it on multiple productions, and I did occasionally bump into the issue with the negative pixel values and thought that was just, very, very annoying. So I tried to fix it in the setup itself, but I couldn't come up with something really clever. So I asked around a bit, and a couple of good compos mentioned to me something about trying to use the multiply and divide math operators instead of the subtract and add operations that we're using in the, obviously, the additive and subtractive setup. So that was all a little bit vague, but it did get me very interested, and I started experimenting. And after a bit, I actually did come up with a solution. So since then, I have to admit that I have not really worked in a company where I could see that they use this kind of setup by default, as in, it's in their pipeline or something. So either I've not been working for the right companies, or this here might actually be a bit of a novel approach. And as such, it could be that this is a setup that might be new to you as well, even if you worked with many different and advanced setups before. Okay, enough about that. So what you actually see here, if I do this, what you see here is actually my own setup and that I used on several shows. And again, I have noted over here that it's not ideal. So this thing here is actually a bit of a critique of myself or my own way of setting things up. And since it is my setup, I do know that it works and I know how it works. So the main thing I'm not really happy with is actually all this confusing spider web of, pipes going everywhere. There is a good reason why it's there though. If we go over here, I have to do this then. If we go over here to this group that says method selector, and you can see you've got these pipes coming in from, multiple sides, you can see that we have a drop down that will allow us to work on things like just the beauty, in which case you would circumvent all the AOV sets, all those shuffle nodes, and you would just do an overall grade on your beauty. We can choose to work with singular AOV sets, or we can, as I normally prefer, set this to all, and with that, effectively work on everything at the same time the way that I really like to do. But of course, it's not really nice to look at. As I said, I don't really like this mess over here. If we look at the other setups, we can see that they're all really made very clearly. I mean, it's very easy to follow where the data flows, all that stuff. Again, this is not the case over here on this one. So actually, I wanted to give this setup of mine a makeover as well for this tutorial. So because we spent so much time going over this combined and additive and subtractive setups before, we went through it in a lot of detail. And hopefully through that, we got a lot more insight as to how these kind of more advanced setups work. I'm going to try and be a bit quicker with this current setup. As you will see, one reason for that is that the setup here uses principles as well that are not exactly the same that we have over here, but similar enough that I think that you're going to get the workings of this setup pretty fast. And for that, I actually already have a revamped setup, so kind of a finished setup if you like, that I just stuck over here. And if we take a very quick look at that, you can tell already that this here looks a lot more similar to this here, right? At least in terms of the layout and things. Now, of course, you can see again that the biggest change that I've made is involving removing all this clutter. So I'm simply thinking I'm going to delete this setup from the scene and just go through the final one, because I think that when I do that, it's going to become clear enough what I have changed and how I've changed it. So let's do that, and I'll be back in a second. All right. I've deleted that first version of the setup as I promised, and we can sort of dive in very soon. Now, first of all, 3 things to note. Number 1, if you look to the left, you can see that towards the bottom of the setup, this here, I made this little part where I take my depth channel, I create a normalized depth alpha, or, basically a mask out of it. And I decided I really like the idea of that, so I've actually just simply copied that part into this setup. So that's that, and then already you can see here at this level of zoom, I can zoom in more and then you can see the difference. But if we zoom out like this, you can see here that the text kind of disappears. And so the second thing that I've done is I've just basically increased the font size on all my labels and my backdrops. And well, just basically so I can read it better. And that's one change. And the third thing is that I have reordered the AOV sets. If we zoom in a little bit then, you can see that over here we've got the lights first, then the materials, then the direct and indirect light. Whereas here I have got material AOVs on the top, light group AOVs in the middle, and direct and indirect light AOVs in the bottom. And that is basically just kind of a cosmetic change that I've made. And it doesn't, you can order these things differently if you want. It's just sort of my own preference. And it doesn't actually have any impact on how the actual setup functions. And then there is another thing, and that is that in between what I just showed you earlier, when I had the other sort of not ideal version of this in the scene, and now is that I discovered that the setup, so this fixed setup here, was missing one pass, the direct emission AOV. And so I have actually added that back in, that's down here, but the AOV is in this case completely empty. However, it was output by the renderer, so I thought it would be best to include it in the setup. All right then, now that's out of the way. Let's look at the top. You can see here that there is a little change. So in this area up here, there's a little change from, let's say, here or here. This one is different, but nonetheless. And what is that? Well, I've got my additive passes coming in here. I've got my beauty here, and then I'm shuffling in my beauty into my RGB and A. So that's all the same. Ignore this grade node, we'll get to that later. But the next thing that I'm doing is I'm shuffling the beauty again. Not the alpha, but the RGB. I'm shuffling it into the B stream here. Again, giving it a name, or basically creating a new channel called beauty only. Why would I do that? Well, by injecting the beauty into the stream like this, I will now have access. So this is my B stream, it's all straight down. I will now have access to a version of my beauty that is clean, in inverted commas, and that I'm not planning to do any grading on in here or do any changes to in the setup. I can just pipe it straight through, which is great because the reason for that is quite simple. Remember that I had at the bottom of my previous setup, or rather just before the overall grade, a method selector. Okay, well, I've kept it, as you can see. And here you can see I have the possibility to grade on all my AOVs, beauty, or basically these AOV sets in singular. So that's actually the reason why I'm piping it in. I can basically inside here, inside this group, so if we open it up, I can, as you see here, shuffle out these singular AOV sets here, as well as the beauty, which I'm putting in the stream at the top. Can shuffle that out, and I can switch to that instead of looking at basically all the AOVs that I've got here, which is sort of, in this case, I decided to keep that as, my first choice, so that would be my default. But if I wanted to do a grade now on my beauty, just my beauty, I could simply switch to that, and I would just basically circumvent all this construct up here. And from that, I guess you can, if you remember, the thing that I was most unhappy with in my previous sort of not ideal setup was indeed that I had all these pipes going everywhere. And they will be coming into this method selector down here. And all the pipes were making a sort of great big mess. And this is the way that I've gotten rid of that. I've simply kind of hidden that kind of construct by piping in these things into the B stream. So that's one thing that we need to remember then, because we did have as one of the rules to keep the number of channels down as much as possible. That's why I'm always putting in these remove nodes set to keep and RGB only, so that we kill information we don't really need in the stream. Well, in this case, I've made that compromise in order, also basically in order to have less visual clutter, but still having the possibility to select here how much of this setup I will utilize. I had to put in these extra channels into the B stream. So it's a bit of a trade-off. I get rid of clutter here, but I get to keep my selection, and I get to have that extra flexibility in the setup. So this time I do have a little bit more data in here that I would have in any of the other ones where I really only have the RGB. I could, of course, get rid of the method selector and not have, so basically always grade on all AOVs, no matter what. Then if I got rid of that, I would lose that flexibility in the setup, but then of course I would not have any need for injecting these kind of AOV sets into the stream here. You will see that I would still need to inject the beauty only though, because there is a second reason for this. I'll get to that in a second. If we look at the basic building blocks of the setup structure, you can see that it is essentially the same as we've already been through multiple times by now. Starting at the top, we have our unpremult, just like before. I'll get to this in a second. Then we have our shuffle nodes, also just like before, like always. And then we've got the remove nodes set to keep RGB, which basically kills any channels we don't really need. So also just like before. So there's no real need to explain that, I think. You can see now that each AOV set here, or here, that each AOV set here is actually a complete, exactly like we've got over here, a complete reconstruction according to the simple additive principle, or basically it's a complete simple additive setup by this stage here. And that is also very familiar to us. Now, the only really little change that I've done is that I made some labels here. I basically made this little backdrop that says don't work here, not an AOV, because this is where we get that little difference, remember? But basically this here is a simple additive setup complete. All right then, that looks really familiar. I don't really think that we need to do much, explanation for this. But then you ask, okay, so where is the change then? Where is the good stuff? Well, let's get into that now. One thing, this here that I didn't, just before I didn't really tell you what this is. This is just an anchor for stamps. The stamps are, if we look like this, the stamps are here. And because in this remove node that we have here, well, you can see it's a remove node, it's keep RGB and this new beauty only channel. This one actually kills, of course, all the other AOVs. And so I had to have one way of getting all my AOVs into these lower setups. And I chose basically to do that with some hidden inputs and a stamp, or stamps, instead of doing any more additional wiring. That's kind of what I wanted to avoid in this setup, just to try and make it look nicer. So that's all that is really doing. Okay then, up here, as I said, we are keeping the RGB from our beauty, deleting the alpha, and we're keeping this beauty only extra channel, or layer, really, a layer that I created. Then, as we know, this point here, we have a completely, in the first step of the way, we have a completely rebuilt beauty by the, in this case, the material AOVs. So that basically means that this point and this point, they are completely identical. And then the next step is this merge node over here. And this is not basically set to, as we had over here in the previous setup, it's not set to from. This time we've set it to divide. And we have the A input coming in from the left, and the B input, as we want it, going downstream. Now, great. The simple question, of course, is what do we do, or what do we get when we divide something by itself? So you already know this, of course, but let's just, for the sake of argument, pull up a calculator and confirm this, just to basically bang you over the head with it. 3 divided by 0 is, of course, no, not by 0, sorry. 3 divided by 3 is, of course, 1. Well, 2 divided by, or 2 is 1. 0.3 divided by 0.3 is 1. So that basically means anytime we divide something by itself, we should get 1. And what would that mean? Well, it would mean that in this case, we would have the first significant difference to the additive and subtractive setup. We should now, once again here, have created a baseline for ourselves, but at this time it's going to be 1 or white instead of black, and that is important. So is it white? Well, let's have a look. Aha, great, we've got white values everywhere, right? And this is when you tell me, but Doug, it's not that great because it's not completely white. We have some funky stuff going on over here. Now, why is that? Well, you are right. There is one corner case that we need to have in our head when dealing with division. And that is, what do we get when we divide by 0? I already made that little mistake over here in the calculator. I wasn't planning to show it to you immediately, but nonetheless. Well, actually, let's just pull up the calculator and try and do that then. So let's do this. And let's pick a number, 2, and then we divide it by 0. We're going to get cannot divide by 0. All right. That means it doesn't really matter, what number we do. We divide by 0, we can't do it. Another interesting case is if we write 0 divided by 0, we're going to get what? Result is undefined. So that basically means that we're getting an undefined number. So mathematically dividing by 0 makes no sense or is effectively not really allowed. But we are a nuke. And clearly we can have cases where our frames have black pixels. So how does nuke then solve this issue? Well, let's just check it out in this super simple example here. So we have just 2 constant nodes over here. And we have basically a merge set to divide as in our actual setup. And what do we get? 0. So the way nuke gets around this is not by giving us an error or anything like that. Nuke simply gives us a 0. What then if we give one side here, the B side, a value? So let's have a look here. And we give it an offset and we set that to 0.5. What now then? We are going to divide by 0 again. And we still get 0. Okay, let's look closely at our render. I happen to know what's going on. And I have to pull up the viewer or gain up the viewer quite a lot. And then we look in this area here. Indeed, as you can see in here, we have a bunch of pixels that are 0. So that basically means that in my render, I probably never had any lights coming into here. Or there's some material in here that basically forces this to be 0. I don't know, but most probably it's just that light or, whether it was direct or bounce light or whatever, didn't really enter into this space inside here. Normally, that's something I would want to fix in lighting. So I would go back to 3D, I would fiddle with this, I would set up my lighting and basically try to make sure that at least I get some values in there. But I decided to keep it in because it actually gives me the opportunity to show you this corner case and also to show you how to deal with it. So if we take our viewer down again, well, how do we deal with it? You can imagine any number, as I said earlier, any number divided by itself is going to be 1 except 0. So what do? This is when we look at the grade node. We simply add a tiny, tiny value. We could use an offset. Well, I suppose we could use a lift as well since we're dealing with the black, but let's just stick with the offset for now. This is a very, very small value. If I switch this on and off and you look here, my render, if I do it like this, you don't really see any real visual impact that this tiny little value have. But if we go down to the point where we're looking to have not zeros, but 1s, and I turn this on, voila. Because I now have a tiny little value in there, or basically erase the whole image because of the offset. As I said, I could use lift. We now actually get a perfect frame of 1. So that's basically the first part of solving this issue. Because of course, the next thing you're going to tell me then is, well, that's all great, but that means that now we've added this tiny value, technically speaking, mathematically speaking, that means that our rebuilds are not going to be 100% identical with our rendered beauty. Well, you'd be right. But actually, of course, we can simply go to after we've finished our rebuild in this overall grading section. And in here, we can just put in the same, or rather a grade node that does the exact same grade, but because it's a grade node, these functions or these operations can be reversed. And so in this one, we just click reverse. And that means we're subtracting this value that we added up here. So at the very least, at this point, we really are back to our rendered beauty. One thing, if you look here, these are expression linked from the top to the bottom. You should see, probably you see like an arrow in which direction the expression links go. So they're linked to this bottom. And we can't use a clone here because if I do a clone and so these are also linked, but they are clones. And if I do an offset here, whatever, I get the offset here. But if I then click this one and I said, I want it in reverse, obviously then the second one or the first one is also in reverse because they are effectively clones. So we can't use clones. In order to do this properly, we have to link them by expressions, but that's all totally fine. So that's how that works. So basically now we've got to this point where we managed to create a completely white frame, exactly what I wanted to have at that point, because this is our new white baseline. And the first step here is kind of done. So then what's next? Let us move down to the second AOV set. As you know, so we're here. As you know, this too is a complete reconstruction. So if I look here, this is a complete reconstruction of the beauty. But this time, we have a white frame to compare it to as opposed to another beauty. So what do we do then? Well, the clue is in the name, of course, divide and multiply setup. Because we simply take this and multiply it. So we go here, we got white, and we multiply it on top of here. Because if we multiply something, any number with 1, we get, well, we get the number we input, of course. So when we multiply or rebuild our rebuilt beauty with a white frame, we get our beauty back again, obviously. So as you can see, then we start with our beauty, then we divide to get a white frame, and after that we can multiply to get our beauty back again, like here. And this way we have now effectively chained these two AOV sets together. But we have 3. So how do we get the third into the mix again? This one here, how do we do that? Okay, so this is where our beauty, let's zoom in, this is where our beauty only layer that I injected into the B-stream on top of the setup comes into play again with its second usage. Because remember, now we got a beauty rebuild here, and if I basically shuffle the beauty only, which is basically the RGB, or I guess I'm doing it with the alpha as well, but I don't really have an alpha here, so it doesn't really matter. Okay, so these two are now again equivalent. So therefore, of course, if we then divide that, boom, we are back to white again, which is exactly what we want. Because, of course, we are looking to get that baseline around which we collect our differences. Okay, and that should then, of course, allow us to, if we go down here, is the final AOV set reconstructed here. And since we now have a white frame, we can once again just multiply it back on top, and we are back to our beauty again. Thereby, we are, and in that way, we have chained all 3 AOV sets together. So that's kind of the way that this all works. So let's just do a quick recap then, just a second time to be sure. We start with our beauty here and our reconstructed beauty here. We divide to get a white frame, which is our baseline in this setup, around which we collect differences, so that we can take the next one, the next AOV set, multiply it. So we back to our, from white, we go back to our beauty, reconstructed beauty again. And then we shuffle out beauty only, divide to get to 1, all good. And then we take the final one here and multiply that on white, giving us, so here's the white, giving us the beauty back. So that's really, really nice. And I guess that from this construct, I hope that you can now see that so we have 3 ways of doing this, and those are the 3 that I kind of know about and have used often. But if there in some other renders or whatever, if there would have been more ways that we could create AOV sets to do reconstruction, you could simply use this same method to chain up any other AOV set if you have one. But, normally this is more than enough. So that means that now we have a reconstruction method that will allow us a great deal of flexibility, I think. And by the way, in case you're still wondering, let's not forget that we have these shuffle nodes. And all they really do, as you probably have gathered, is that they are adding these. So here we got the material AOVs, this one. We have also now our light groups. So, I mean, I already went through this, but these shuffle nodes here where we inject each AOV set, each reconstructed AOV set, is of course just because we've added this method selector here so that we can basically restrict ourselves to grading on just a beauty or any of these singular AOV groups. But for the most part, I really just leave this to all because I actually really like being able to grade across everything and have full flexibility of the setup. And, you know, that was this kind of trade-off. Instead of getting all these wires, we are injecting a couple of layers into the stream. But of course, after we've selected the method, we don't really need them in the stream anymore. And that's why I got a remove node down here set to keep the RGB, because from this point on, that's really all we need. And all that's really left is this overall grade section where you remember we have a grade node here to reverse the offset we did. And as I said, we maybe probably should be using lift, but you know, we did it with an offset in this case. The offset that we did in order to deal with these black pixels, because you remember in here we have black pixels, which we don't like to have, but this was all dealt with here and we're reversing it. So everything should be completely equal at this point. Then at the bottom, I do want my favorite blacks match gizmo from Tony Lyons in the setup to do my, well, you know, blacks, obviously. And then really we just have the beauty here with our alpha, which obviously in this case is just white, shuffling that in to do our pre-mult, and we are kind of done. That should be, well, actually, you know, we have the depth stuff here, but there's one little thing here. I'll get back to that in the end. But other than that, this is basically the run-through of, let's frame this, yeah. That is basically the run-through of the entire setup, how it works. So I think that the next thing should be that we should just confirm that the grading actually works as it should be, as we expect it to do. And then I have another couple of things to say. Let's just throw a few grade nodes then into our setup, and let's just do a bit of work. So shall we do, what shall we do? Shall we do diffuse? Let's put one on subsurface scattering. Let's try and kill this one again. Let's put one on top fill maybe. And indirect diffuse and direct glossy reflection. Okay, so now we have a few grade nodes in there. Let's have a look at the bottom of our setup, what's coming out of that. And let's just do some adjustments. So we can see that we can take this down and up. Let's just take it up a little bit. Let's make a brighter image for now. We've got this. Let's increase the gamma a tiny bit. Yeah, you can see that's working. You can see it's also affecting the grapes. Okay, so we can adjust those. And then we had the fill light. We said we're going to kill that. That goes off here. Top fill. Let's make the top fill a little brighter so we get a brighter image. It's kind of in a soft way. And let's go to the last one, indirect diffuse. Let's just give it a bit more bounce light with our gamma. Great. Direct glossy reflection. What should we do with that? Should we boost it? Take it down? Let's just boost it like this. Okay, so we have a brighter image. You can see things more clearly, and as you can see, it just works exactly like you would think it should work. But let's have a look here as well, just to make sure. Let's turn off this one, and let's go in here, and this one, where we have our white frame. So here you can, once again, we'll just observe that what we are actually doing, when I turn this on, so we know exactly, because the subsurface is really only on two objects, so it's pretty easy to see what that's doing. Let's put them to 1. And if we measure here, we have 1. And as you can see, as I'm moving up, those values down here are increasing. Basically, everything else around it is still 1, because it doesn't have any subsurface scattering, but where we do have it, we get increased values, and then we're lowering our values, we get decreased values, but since we are at 1 for our kind of baseline, the difference that we're registering here does not result in negative numbers. Okay? You see, darker, brighter, darker, brighter. Okay. So I guess that's kind of good. Yeah, so it's working. But at this point then, we are more or less at the same stage of testing as we were at some point over at the subtractive or additive and subtractive setup over here. But remember, the primary reason for creating this setup in the beginning was to solve or to counter the issue that we have with our other setup, where we can have, or where we have the potential to get negative values in this model, negative pixel values. So this is kind of the primary reason for creating this setup, and we do need to kind of prove our point that actually this works better here. So if I then go in here, let's activate all of these, let's set them all to 1. 1, 1, 1, and this one again. So now if I put my viewer to 2 here and 1 here, and you can see I'm flipping back and forth, the result is the same. So these grade nodes here don't really have any effect. And now let's actually try and do a direct comparison on the fly by cloning these ones. So we got a grade in the combined diffuse. We want that over here as well. And I know that they've been switched here. So this is the combined diffuse. That's 1. And another clone for subsurface scattering. And that will be here in the other setup. We've got 2 nodes here. Well, they are fill and top fill, I think. So where were they? Yeah. Screen left and top. Those are those 2. And then we can do these clones, indirect diffuse, direct glossy reflection. And the last one. So that would be these 2. Okay, so now we have cloned. You can see we're cloned. So we are doing the exact same grades on the exact same passes in both setups. Let's just verify that this works. And if we take one of these up, let's just do the diffuse first. Just make it very bright. We should see that there's still no difference. Okay, let's maybe do a wipe. Okay, that's all good. Now, let's try that thing where we are grading stuff down a bit. So let's look at our 1 here. We're grading this down. Then we go to the subsurface scattering. We can grade that down as well quite a bit. And fill light, remember we wanted to kill that. And let's take the top light down. And then we got indirect diffuse. We want to reduce that as well. And glossy reflections. Let's also take those down. So now we have we're looking at our current setup. Whoops, this is 2 and this is 1. Actually, we see a clear difference. We can see a clear difference. So this is our current setup. If I just kind of do this, actually, let's see, here and here. Switch them on and off. Okay, so we are grading things down, definitely, and we're comparing them to this setup over here. This does not look the same. This does not look the same. And let us now actually boost our viewer a little bit to see what's going on. Can you see this? This is indeed our add and subtract combined setup, and it is getting these broken colors. Whilst over here in the divide and multiply setup, we are getting, if I take this down, we're getting an ugly image. This is not a brilliant grade or anything, but we have not broken anything yet. Can you see this? It looks kind of like much more of a natural darkening of everything. Nothing is broken as of yet. But in the other setup, actually, so this is 2 and this is 1. Okay, now we have to switch them on again, sorry. And let's do a wipe now. You can see that things are getting, for 1, it's getting much darker looking over here. And we can see kind of why, because we're breaking that barrier with the negative numbers already in the background. But we have a lot of ugly artifacts and sort of broken colors. Just look here as well. We got this sort of blue color. with the other ones in the negative, and you can, well, actually you can see pretty well here when we're doing the wipe, you can see what these colors are doing and what these colors are doing. These all remain in the positive domain, whilst these, in this case, this pixel here is in the negative, both in the green and in the red. Only in the blue is it positive. And that's why, of course, you're getting this light blue coloration here. So this is basically a visual proof. And look here. Look over here how broken this looks. So let's actually see how far we're going to have to undo this in order to have no issues over here. We can already see, so if I turn this all the way over here, we can already see, as I said, this looks dark and ugly, but it doesn't look broken. So let's do this then. Let's go back and, you know, increase this again. Some colors are coming back, but you can still see how ugly this stuff looks up here. So put this one, this is the reflection one, and take the indirect diffuse, put this one on, aha. Now we're getting back, we're still looking, you know, we're still getting bad looking colors. Take that all the way to 1. I think, yeah, you can see even here, still negative in the blue. Let's move on. We have the fill light, so let's do the top fill. Okay, so now we're getting back to something. But remember, actually let's put our actual beauty, which I have here, let's put that on 3. 3. So we're darkening down. Remember this color here is a pretty good indication as well. So we're darkening down. This has a sort of bluish, neutral, well, not really neutral, but sort of bluish, grayish tone. And if we're looking at our current setup, you can see what that's doing to the color. And then we're looking over here to the subtract and add setup. And the color isn't just that it's in the negative, it's also completely warped. I mean, this here, you can at least see that it's retaining some, from all the darkening that we're doing in all these layers, it's retaining some of the feel of our actually original. So I would say this is a far better look. Even though our grade is ugly, this is a far better look. And remember, now we are still boosted. We're still gained up pretty high here just to see the changes in the dark areas. So I was here, and then also remember, of course, when I'm grading these, I am grading the corresponding nodes on the other side. Remember that we flipped these two in the setup, just because I want the layout in terms of order to be different for my setup. So that's why it looks as if we're doing something different, but we're not. These are the same. These are the same. Okay. So let's move on then. Let's put that back again. And we've got on 2 and on 1 and 2. Yeah. So now we're back, and let's do this up. See here now, I think we are now grading our 7. So we're grading the top fill, and that's why it's affecting this background quite a lot. And here we have to basically bring it back all the back to 1 before it's almost the same as the other one here. Like it's getting the colorations back again. As soon as we do this, you can see we are messing a lot with the colors, and then they start to go in the darks or in the negatives. Okay, so that's that one, and this one we killed, I think. But actually, let's put it back to 0 and put our wipe kind of across it. So over here, not too much of a difference, but now we have, of course, increased our levels across the board quite a lot already. So now they should look very similar, and they do. And the reason for that is, of course, that now all of these are now at 1. So in this case, right now, we're actually grading only one AOV set. And as I remember saying, for this setup, if you grade down across only one AOV set over one criteria, essentially, then you have no problems. So this, as long as we're staying inside of 1, they should give you the equal result, which they give. You know, if I wipe here, and I can take this down, see? So now they should be giving you more or less the same result. Take it back to 1. But the moment I introduce something to, that's not a really great example. Let's do this one. What was that? And let's take that one down again, because the diffuse is quite influential on a lot of the pixel values in this image. Now you can see, as soon as we start to introduce values in both of these setups. So in other words, as soon as we start grading across setups, we have one setup, our divide and multiply setup, that works really well, and one that does not work as well. And that very quickly gives us these really nasty artifacts. So I would say, so let's put the colors back. Let's take these off. And let's take the viewer back. Get this off. I would say that this is pretty much proof that the divide and multiply setup that we've done now is solving the issue that we have here. We don't seem to be breaking the image when we're grading down across multiple AOV sets. So in other words, I really do think that this setup is better than this one. In other words, I think this is the one to go for. All right then, so let's say then that we like the divide and multiply setup better on these grounds, but and we think that it works better. But why does it work better, do you think? I believe that it is quite possible that you guys have already figured out why, since I have kind of been going on about this for a while already, but let's take a little bit closer look again to be sure. Now, because of the division operation, so let's actually do something here. Let's move in, put a grade node that we can play around with just for an example, and let's put down a color lookup node as well. The color lookup node we can have here as a kind of visual reference. Let's set the thing to 2 so that we can have both of these up. Yeah, as you can see, this is a nice way to visualize the same type of thing that's going on in our grade node. So hopefully you can see this. Note as well that in the grade node, we have a black clamp, which is on by default and which is really good for most cases when we do grading. If we want to emulate this over here, we'll have to select the thing that is, this thing here, that is sort of our black point, and we have to press L to create a linear interpolation, and that effectively flatlines this side of things, meaning that we have the same thing going on here now as with a black clamp on in the grade node. And therefore, when we pick our point here and we move that up and down, you can see the values change over here. That is the same in a more visual way as doing this. Whoops, not the offset, not the case, but with the multiply and gain, which is what I'm using for most of these examples, because I like to grade with grade nodes, so that's why I'm usually putting those in for our examples, and I'm going to stick with that for now. But visually, moving this thing here up and down is pretty much the same as doing a gain or a multiply, right? And also in the color lookup node, we can more easily also visualize the fact that we know that we used to have a baseline around 0 in the combined additive and subtractive setup, and now we have a baseline around 1 or white, which is the current case, and we can see that more clearly here compared to here. Anyways, so if we go down here, when you grade something down using the multiplier or the gain, which are the same, or even the gamma, as you can see here, we start with an input, with a value of 1 here. So if we take the multiply, that simply means in our grade node, we multiply the input, what's coming in here, with 1, which means no change, right? And then we move the multiply down towards 0, which means that we're multiplying something with 0, we get black, right? If we do that here visually with this node here, we can see that, we're moving things down, we can see how this curve responds, and if we put that to 0, we basically flatline everything. That means that whatever, coming into these nodes, we've multiplied it down to 0, we have effectively removed all that information. We have nothing left, there's nothing there. And of course, we don't need to have less than nothing. We don't multiply or gain by negative numbers, at least not when we're doing normal grading of CG. And yes, I know that there are cases where we can play around with black points, etc. I know that there are cases where we can, switch off the black clamp and do various things. But that's usually for other things than straightforward grading of CG, and is not really relevant for our current case here. So what we have actually done here is that we have killed the image. We've made whatever, if this was an AOB, we've now basically made that AOB completely black. And if we look at this then, actually, so if we now look at this one again, let's move this up a little bit. If we take this as our example, we want to grade things down all the way down until we get completely black, remove all the pixel information in that frame. Well, with this setup that we have now, with the baseline up here, we have all this range here from white to black to play with when we grade stuff down. Remember that grading things up, that's never really a problem in both of the setups or these more advanced setups that we had, and any other setup for that matter. Grading stuff up is not really a problem. It's the point when we're getting closer to 0 that is. And here we remain in this range between 1 and 0. The entire time we are in positive pixel value land. So I hope that is at least one further explanation that could help you understand why this is actually quite a lot better. And with that, let's remove these, and I think maybe we can just do a bit more of a drastic example next. First, I'm going to take these, and these. Whoops, not that. Get these away. Right, let's do something like that. And yeah, let's do something quite drastic next to have another look at stuff. Okay, let's pull down an entire AOV set to 0 and let's trace that through our setup. Let's just do it up here. So let me do a grade here and clone this for all of these just so we're having less hassle. Over here again, like this. All right, so I'm looking at this, and let's just do that grade down. So we're grading down, 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 and we're going to 0. As we can see, we just have 0. All right, then in our setup, we have our beauty. We now have graded this, and we've killed the entire image, and we get to this division operation. Okay, so let's bring up our calculator again. Let's try that, and go for any number, so 2, whatever. And then we want to divide that by 0. The calculator said before as well, said to us, cannot divide by 0. And as before, we know that nuke kind of has to give us something. It's not going to give us this error. So it simply gives us a black frame. All right, it's still black then. So that's pretty good. That works great for us. Oh, and also, by the way, when we use division as an operation, let's turn this back to 1. We need to note that just like with subtraction, the order of operations matter, meaning we need to make sure in our setup that the A and B inputs are set up correctly. And since we want our B pipe to flow down like that in all our setups up until now, we have the B pipe coming down like this, and the A pipe is going into this to the side here from all of these AOV sets. So that's basically how we need to set that up, just so that we don't forget that division means that order operations matter. So we have a 0 here then. What happens next? Well, the next step is we take our 0 down here, and we've got our beauty, and we multiply that onto the previous result, which is 0, and that also is obviously going to get us 0, because anything multiplied by 0 is 0. Then it's the same song. We have to get back to this division operation, or we don't have to get back, but the next thing is the division again. And exactly like above, when we divide with this current 0, we also get 0. And the same thing again here. We have a beauty reconstruction here, multiplied by 0, and then we're kind of done with this main thing here. That's kind of that. So that basically means that when we do this grade to 0, we can trace it all the way through the setup. All is good. And when we've done, so this is an extreme thing. We've just said we're going to make this entire image black up here in this material AOV set. Killing everything is all black. Any sort of grading that we do after that, that's not really going to matter, is it? Right? Because we've already told the image to be black, and we've traced it through the entire setup. So if I do, I multiply this up by a little bit. So now I go over here, have a look. All right, so I multiply this. Well, whatever the result I have here, or gamma it up, whatever it is, if my incoming, in the B pipe here, if the result there is 0, doesn't matter what I have here, I still get 0. So, I am here, I can do whatever grade that I want. If I've set everything to 0, well, any other grade that I do later isn't really going to affect the image. But, you see here? That is exactly how we want to have it. And again, that just shows that the system does work, I think. So let's do that. Let's go in here and put this up again. Actually, I think that should demonstrate that enough. We can just get rid of those again. All right then. So by now, I hope that you have a good understanding of how this method works, as well as why I prefer it over this combined additive and subtractive method. I see we have some great nodes in here as well. We can get rid of them. And I did see one thing over here. Yes. Okay, good. My thoughts is that in here, I have the full flexibility that I was looking for this whole time. I don't get these issues with the, destroying the image with the negative pixels. Certainly not the way that I get it over here. The setup itself, when I'm looking at it from far away like this, it looks really readable. It looks straightforward. It's built according to these criteria that we had in the beginning. For the most part, there was one thing, because we are introducing a couple of layers into the stream. We do have maybe a little bit more data in the B stream that we do have over here. However, that is because I wanted the extra flexibility of this being able to pick methods, or being able to pick to just grade maybe one single AOV set. So that gives us more flexibility. And by putting them into the stream, well, as I've already said, that hides all that extra wiring that I did in the setup we showed first, the first divide and multiply setup. That was not really ideal. And oh yeah, there is just one little thing to go before I forget. And that is this little expression node we have here. So if we look at this one, this is for the depth. So let's have a look at the depth then. I almost forgot that, but let's just go through that for a second. So we see in the red channel down here what values we have in our depth. And sometimes when you have renders where, in this case, it's not the case because I have a backdrop about 3 meters or so behind my main scene. But sometimes it could be that you get very extreme values in the back because maybe you don't really have much in your scene and whatnot. And I have seen examples where that could sometimes cause issues on edges when you're doing Z2 focus in places like this, maybe. And so sometimes I think it's a good idea to kind of clamp, to make sure you can clamp values to something that is a little bit less extreme. And this is what this expression node is helping us do. You can see here from this expression that I'm basically telling it that if the Z is, so basically if our depth is higher than whatever threshold I set up here, then put a max value in. So basically clamp it to this, which in this case 4. Other than that, put it to whatever it is. So let's see, I've got 3, 6 here, and let's just put these to 2 and 2. And then we'll see, when I switch this on, you should see now this. All right, so now all these values have been clamped to 2. But maybe I want to clamp them to 3. And I want to put this to 3. So now we get back our table. But I remember that it was actually 3.67 or something around that. So if I put this to 3.8 and 3.8, clamp it to 3.8, I now have all my values in there. So what I would normally do in this case, I would find the furthest away point, and then I would add some number to that and use that as my clamp value. So I would go, a little bit over the furthest point that is relevant in my scene, and then I would put a clamp value in according to that. It was a little bit higher, so I get rid of all these extreme things. That's really all that is doing. There's no magic to it, and you can see from the note here that this kind of clamping, you need to adjust that at a shot by shot basis, because of course various shots have different depth values. And that's really, as far as I'm concerned, that is kind of it in terms of going through things. And and with that, I would say that we've gone through the divide and multiply setup in enough details for now. And I hope you understand how it works, and I hope that you can see the benefits that it has over other ways of setting things up. Next, I think we should maybe try and discuss a couple of potential caveats before we can wrap things up. Okay, I just mentioned caveats. I suppose that's probably not the best description though, as this setup here is really solid. Perhaps pitfalls would be a better word, and I can think of one pitfall, so let's have a quick look at that. If you look here, I've added a grade node to my combined diffuse. If I switch this on, so let me do that, switch it on, you can now see, if I up my gain a little bit here, you can now see that the image now appears broken in a similar way that we broke the combined additive and subtractive setup. So why is this happening? Well, if I select the grade node, we see two crucial things. Number one, there are actually negative numbers or actual negative numbers in our multiply over here. And number two, the black clamp, which is always on by default, is now off. So what does this tell us? It tells us that if you deliberately or indeliberately input negative values into whatever you grade, and you do not clamp your blacks in your, say, grade node, well, then you can break the setup. However, and this is important, that would in this case not really be because of an inherent flaw of the setup, but much more because of simply bad habits or bad working methods. So let's zoom out. And it is not just a problem with this setup, but also with other setups. You should not input negative values in general when grading, or at least when grading CG. Now, of course, there are always some exceptions. Sometimes you might want to not clamp the blacks and then pull things into the negative, but that would not really apply to when you do a normal standard grade for CG like here. So therefore, if you stick to input values from 0 and upwards, this setup should still work just fine for you. So let's just do this, take everything back to normal. Okay, so one note on grade nodes. Just as you can see, black lamp is always on by default. You've seen me using almost exclusively grade nodes throughout the tutorial for various examples, and there are a few reasons for this. First, it's very convenient, of course, since I just have to press G, click here, and press G, and I have myself a grade node. Secondly, I like this node precisely because it does clamp the blacks by default. And it is, for my own taste, the simplest and most straightforward grading node to use. So in my case, I will almost always start with a grade node. And if that then is not sufficient, I might add or replace it with a color correct node. And if that is still not enough, I'll look into using some other node for tweaking colors. Now, this is, of course, my preference. I know that other people have other preferences, and that is just fine. But the crucial thing to take from this is it is really nice to know that you will clamp the blacks by default when using a grade node. So you don't actually have to think about that when you're doing it. On the other hand, if I do a color correct node, if you were to use a color correct node, be aware that this node does not clamp blacks or clamp blacks by default, and as such, you would be advised to not use the offset slider on this one. Okay? The gamma and the gain should be fine because they should be leaving the blacks alone, but the offset should be used with much caution. In the grade node, again, over here, it doesn't really matter because you have already clamped your blacks. So just keep it as a general rule when you're grading CG, or any other grade for that matter, to not use values below 0 no matter what kind of node you use for grading. Okay, let's delete this. I hope you see that this pitfall, which is actually a general one, is not really going to be much of an issue when using the divide and multiply setup, if you stick to the rules. Okay, so what else is there to mention? I suppose I can mention one thing. For the entire duration of this tutorial, I have, as you know, used only this one rendered image here. We've been using this the whole time. And as I said in the very beginning, it has been rendered with Houdini's native renderer Karma. When planning the tutorial, I decided that I was only going to render out AOVs that I consider to be standard and that are easily available when setting up the output from Karma. And that means that I have not rendered more specialized AOVs like shadow passes, raw lighting, etc., etc. I think there's an albedo in there, but that too was not really needed to demonstrate the various methods that we've been going through. For some of these other passes that you might get, or combinations of such passes, it could be that you are not going to be able, so if we go back here, it could be that you're not going to be able to simply add them into the stream, like here, using, if I double click it here, using just a simple plus operation. You might have to do operations like divide and multiply against other passes or other results of operations before you can add the result of that into the stream via a plus. So I decided to keep things a little bit more simple and stick to more standard passes for this tutorial. However, if you find yourself having to implement a few such more specialized passes, it would not really be much of a problem, at least not if you use the simple additive or the divide and multiply setups as your starting point. And this is because whatever you need to do in addition to your starting point is going to take place inside an additive setup, at least almost always. And also inside one criteria at the time. So inside an additive setup and also inside, whether it is a material, a light group, or indirect or direct light AOVs. So therefore, in the case of the divide and multiply setup, you should not really have to change the overall setup at all. So if I zoom out again here, you shouldn't really have to change the overall way that this is set up because the principle still works. You should just have to make sure that you augment the AOV sets with whatever extra passes you have. So you're going to be working probably within one of these with extra passes, and then the rest of the setup and the method itself will keep on working, or will just simply work. All right, we're almost at the end. I guess I can zoom out again. We're almost at the end here. And if you've managed to keep your eyes and ears open through the length of these videos, you should by now have a thorough knowledge of these 4 setups over here. The simple additive, the simple subtractive, the combined additive and subtractive here, and the divide and multiply setup. And I hope that you've also picked up some additional knowledge, some do's and don'ts, etc. on the way that you can use to improve setups whenever you see that something might not be optimal in whatever it is that you've either created yourself or is being handed to you. Now, as for preference, I've already stated that I do indeed like the divide and multiply setup, and I think this might be the setup that is possibly the least known to people, at least judging by my experience. So I would definitely encourage you to try it out for yourself if you haven't already. But I think that both the simple additive setup and the simple subtractive setup are great as well, especially if you only have, say, 3 or 4 AOVs to grade, or if you are only given the chance to grade within one single AOV set. So for simpler things, they are perfectly fine. But if you need the full range of AOVs for maximum flexibility, the divide and multiply setup has been my go-to method for the last couple of years. I used to use the combined additive and subtractive setups earlier, but due to the potential issue in grading down or darker, I've switched to the divide and multiply setup. So basically this one is now my current favorite for whenever I need to grade across AOV sets. And with that, I think I will draw the line here and simply say thank you for taking the time to go through this tutorial with me. I hope you could learn something from all of this, irrespective of what level you're on in terms of compositing of CG. And if you liked what you've seen, then please consider liking the video or hitting the subscribe button. That would of course be nice. So once again, thank you very much for following along and have a nice day.